Alright, welcome to the Man World Boom, and I thought I'd do a little tech review science trial thingy. So I'm busy with my computer water cooling loop. Very nice custom build that I think is going to come out really nice. And I bought this overkill radiator. It's the EKWB Extreme version, the quad. So as you can see, it's 60 millimeters thick. And I went dual fans, so I got 8 fans on both sides, or 8 in total, at least 4 on each side. And I thought I would, before I finish this thing, I would actually just hook this up and see how much cooling performance it can actually do. So what I'm going to do, I've got over here, I've got a solar hot water pump. So a solar hot water pump can go up to about 60 or 95 degrees, I think, Celcius, centigrade, which is just about boiling point. But generally in engineering, you sort of put the limit way lower than the actual capability of the device. So yeah, if you say an elevator can handle 800 kilograms, it can carry much more than that before it actually fails. So I'm hoping we'll go beyond that, but that's not the point. I actually want to test this. This, on the other hand, I think only rates up to about 60 degrees. I forgot the thing, but anyway, it's way below boiling point, and I want to sort of push this thing beyond and see how far it goes. Then I've got this silicone tubing. So silicone, as you know, well, I don't know if you know, but it goes up to about 2,500 degrees centigrade. So this is not at risk at all. The things that I do think are at risk though are the little O-rings. So these are just pushed into little barb fittings, but there's little O-rings there, and they might give us some issues. And then I've got an old kettle here, and the base plate failed, so I soldered into the main wires. So the switch doesn't work, and it's basically a throwaway, so I thought I'd use it for my little experiment. But it's a plug-in and it stays on kind of system at the moment. So if I plug it in, it's on and it's going to stay on. So the first thing I have to do is I have to prime the pump. So I've got to get this water through the pump and the radiator. So I thought the best thing to do was to solve the little air in the system problem, was just to put it under the tap and force water through the whole system. So I got it here at the kitchen sink. No, it's going to run down my arm. No! I just squirted my computer. So after about 3 attempts and a plumbing leak fix, I finally have a primed system and it's running, and you can have a peek in there. Just have a look at that steady water flow. There we go, you can see it's steadily flowing. Very good. And I've got my computer on, I've got my temperature gauge ready, and I'm ready to do this little test. Something's wrong with my fan controller though. So these are all plugged into the 6 inputs of the Commander Pro. It's 1, 2, 3, 4, 5, and then the last 3 are plugged into a splitter, so they on channel 6. But if I feel there, this one's definitely turning slower than that one over there. And if you look at the back here, I've got some beautiful toilet paper streamers. You can just take there. You know, that's you can see this one is sort of hanging, and these ones are a lot more upright. So definitely there's less airflow going through the top one, which I don't know why. I mean, obviously my computer is not actually on, it's just the power supply that's on. So let me flick the switch for the kettle and let's see what happens to the temperature. So first of all, I suppose we've got to get the initial reading. We'll stick that in there. Come on, in you go. You know what I can actually do? I can stick this in the return line. There we go. So now it's reading inside the return line, and we've got 21 degrees there, so it's actually coming out the radiator. So let's flick that switch and see. There we go, kettle's on. So this kettle draws about between 1850 and 2220 watts. So we're going to call it roughly 2000 watts. I can maybe benchmark the kettle later and we can see. So the goal is to keep it under 65, and you can hear the kettle's already humming. So it's going to be interesting. It's going to be real interesting to see what it's doing. You can already see the temperature's rising a little bit. Going up 21.8, 22 degrees. So how physics works, thermodynamics works, is you got a delta T, a temperature differential. So the greater the differential, the easier it is for the heat to dissipate in this example. But the temperatures want to equalize eventually. If you've got something really hot and you leave it in the air, it's eventually going to get to the temperature of the air. So it's going to eventually reach the temperature of the air. So initially that curve isn't very fast, but as they get further and further, the curvature gets, so what we're going to hopefully see here, it's going to stabilize at some point, and then we're going to see what it's doing. So it's already hitting 28 degrees now, but I mean it started at 20 degrees, so it's still quite a long way. This is obviously degrees centigrade, Celsius. So America with Fahrenheit, you're wrong. You're wrong. Water freezes at 0, that's Celsius, and it boils at 100, that's Celsius. So very simple 0 to 100 scale based on water. And Fahrenheit makes no sense whatsoever on Earth. That's why progressive, forward-thinking people use Celsius. I'm just kidding. It's just, anyway, I use Celsius and most of the other world. We're still going up 34 degrees. It's going slowly. You can definitely feel there's heat here. Definitely feel there's heat. There's some heat on this side of the plate being vented quite badly. Definitely, there's a lot of heat coming off this thing right now. You can feel it's like a blower fan, like a heater. That's a lot of heat. 39 degrees. 41. Kettle's humming. Maybe let me get like an input temperature. It's at 42 now. And the water in the kettle itself is 50 degrees. So it's going into the radiator at 50 and coming out at 42. There we go. Back in the return line, 43 degrees, almost 44. There we go. That's probably nice and toasty now at the back there. 47 degrees. It's probably hot. $53, $54. It's going very slowly now. It's at 56.9. 56.9. It doesn't seem like it's going much faster beyond that. 57 now. Now I wonder how good it will do with this thing. The top fan's actually working at full speed, because they're not performing good at all. There it went down again. It went to 58, now it's back at 57.8. So it's coming out at 59.5 now. Let me just get an input reading again, see how much that is. Input 66. 66.5. Okay, back on the outlet again. 59.9, 60, 59.9, 60, 60.01. It's amazing. It's amazing, state of the art. Top, what, cutting edge science test. Okay, so I'm gonna let it look like it's stable at 61.5 now, so I'm gonna let it run for 5 or 10 minutes and we'll see if it goes up. But I mean, we're looking for a my wife is surprised, but we want to get a stable running temperature and then we can say it's benchmark at that temperature. So it's looking like it's going to hold under 65, then it's a 2000 watt cooler. 2000 watt cooling capacity. That's outrageous. And with some booster fans on, if we put if you put serious fans on with high airflow and high pressure, it would be probably well beyond that, I'm sure. So anyways, it's impressive. It's seriously impressive, I must say. Okay, so it looks like we have stable operation, and you're not going to believe it, it is on 65, exactly on 65. So it's slightly above now, 65.1, but it's sort of sitting at between 64.5 to about 64.9, sort of on stable, and it must be very close to equilibrium now anyway, so even if it goes up a few more degrees, I think it's fairly safe to say that this is very close to in the region of about 2000 watts of cooling performance as it stands right now, which is amazing. I think it's complete overkill for your computer system. Yeah, it's super toasty at the back there. So output temperature right now is 65.1, and let's just see what input is. It's getting dangerous now because this is pretty hot now, so if I stick my fingers in the wrong place I'm going to burn. So I'll stick that in there, and that's sitting at 73 input, 73.6 input, and let's just for interest's sake have a look here. So your input ambient temperature is about 22 degrees, 21 degrees going into the fan, and on the back, see how much is blasting out there. 49, 50, 50 degrees output temperature, 53 degrees output temperature. Yo. In a nice spot there, 56. So that's your output. So it's about over 50 degrees output air over there, and this thing is actually remarkably cool to the touch. It's the only hot spot over there is over there, and then obviously these pipes are pretty hot going into this thing, but silicone doesn't mind the heat. Get it back in the outflow tube there. 61, 65.1, 65.3, so it sits stable at 65. So there you go, 65 degrees, 2000 watt kettle, and it keeps it there. Wow, it's amazing. So I'm super impressed. EK, I'm super impressed. Corsair, I love your fans. So these are the QL 120s. They're pretty expensive though, but they're really pretty. So anyway, it's an aesthetic system. It's going to be nice. That's it. So if you enjoyed that, give me a thumbs up and a like and a subscribe and all that stuff. We'll see you next time. Bye. So the first thing I've got to do is disassemble my toilet cooler. So if you haven't watched that video yet, then be sure to check that out. This is the cistern float valve, shuttle valve thing in my hand. Every water cooling rig has one, obviously. Basic piece of kit. So let me disassemble that and I'll come back and we'll hook up a kettle to my cooler, and in the name of science we will see what the results are.